In this video, we'll be learning how to use simple formulae. This video is a great way to start the algebra series. For this activity, we're going to start by finding and applying rules. We're then going to move on to substituting letters for a value. And finally, we're going to convert currency using a formula. In the first group of activities on your worksheet, you're going to learn how to apply a rule, how to find a rule, how to reverse the rules, and also how to use a multi-step rule. If you feel confident, you are welcome to have a go on your own. Otherwise, if you stay with me, we'll go through some of these skills together. Okay, let's start with using a simple formula or a simple rule. In this example, we have 4 different numbers on the left side. We are applying the rule multiply by 6. This is our formula. Our formula is our rule. It's what we're going to do to each number. On the right hand side is what the new value would be after our number has had the formula applied to it. So if we take the number 3 to start with, we're simply multiplying it by 6 and then writing the new number in the right hand column. So 3 times 6 is 18. So I would write that in the right hand column. Let's take our second number, the number 5. We're applying the rule times 6 to it. So 5 multiplied by 6 is 30. You may have come across function machines before where you're doing the same thing. You're taking a number, you put it into the function machine and it comes out as a different number. That is an introduction to algebra. That's an introduction to what we're doing here. We're just taking a number, applying a rule to it, and then that number becomes something else. So our next number is 8. We're going to multiply by 6 to it, and that comes out as 48. And our final number, 15 times 6, you may be able to do this mentally. If you're unable to do it mentally, there's no reason why you can't do a written method. You may do it like this, you may partition it, whatever works for you. So 5 times 6 is 30, 1 times 6 is 6, plus the 3 is 9. Very quick way to quickly calculate it if you're not able to do that mentally, or if you want to make sure you've got accuracy. So that's our first one done. In our next activity, we've got our beginning number and our end number, so we know both values before and after the rule has been applied. What we need to figure out is what was the rule? What formula was being used here? How did my 3 become 27? How did my 5 become 45? And so forth. Now you may recognise it already. You may straight away see the pattern. Sometimes we can see it straight away, other times we might need to work for it. I'm going to assume that you can't already see the pattern, and we're going to work through this logically. Now, what do we know? We know that the number on the right hand side is larger than the number on the left hand side. So we know this. The left side is smaller than the right side. So therefore, it can be one of 2 operations. We might be adding, or we might be multiplying. We need to figure out which one it is. So at this point, if you haven't spotted it, let's work through systematically. What would we need to do to 3? What would we need to add to it to get to 27? We'd need to add 24. We'd need to add 24 to 3 to get to 27. So that would be our rule. We need to check now if that rule works with the other numbers. So let's start with 5. If we were to add 24 to 5, would it equal 45? Hopefully you've seen now that it wouldn't. 5 plus 24 would actually equal 29. So we know that it's not adding one single number because that didn't work. What about multiplying now? Let's have a go at multiplying. what would we need to multiply 3 by to get to 27? Well, 3 goes into 27 9 times. So now let's check whether that works with the other numbers. 5 times 9 does equal 45. 8 times 9 does equal 72. And 15 times 9 does equal 135. Now I appreciate you may have to do a calculation to figure out if 15 times 9 equals 135. But the main thing I would like you to understand here is once you've tested it out on one, you need to make sure it works for the others. So in this instance, our rule was multiply by 9. In this next example, we've got our rule and we've got our end value. We don't have our start value. So we need to find out what was the value before we multiplied by 8. So to do this, we need to undo the rule. We need to reverse it. And the correct mathematical terminology for that is we need to use the inverse. So what we're going to do is take each number and divide it by 8, and that will tell us what the starting number was. So let's start with 32. If we divide 32 by 8, we get 4. We just check. 4 times 8 is 32. 32 divided by 8 is 4. Let's go to 16. Let's undo the multiply by 8 by dividing it by 8. Well, how many 8s fit in 16? It's 2. And we can check 2 multiplied by 8 equals 16. Next we're going to go to 96. 96 divided by 8 is 12. So these are all still in your 12 times tables. The next one is slightly larger than up to your 12 times table, which you need to learn. So if you're not sure, you can do a written method. Eight into 1 doesn't go. 8 into 12 goes once with 4 remainder. And 8 into 48 goes 6. And there you have it. That's how you find the starting number before the rule has been applied. You simply use the inverse. So next we're going to look at what happens when you apply a rule that has more than one step. So previously we've been looking at rules that only have one step, such as just multiplying or just dividing. But we can also combine 2 steps into our rule. So here we're actually given what the rule is. We know what formula has been applied and we've got our end value. Just as before, we can use the inverse. It's important to note that when doing the inverse, that we undo the step that's being done last. So if we had a starting number, we first multiplied it by 5, then we added 3 to get to 33. What we want to do is undo the last step first. So we want to undo the add 3. We need to find the inverse of adding 3, which is subtract 3. And then once we've got that value, we need to undo the multiply by 5. So we need to find the inverse of multiply by 5, which is divide 5. So if we write it out as a new rule, we want to subtract 3, then we want to divide by 5. So let's have a go at doing that with our 33. If we subtract the 3 first, we have 30. Then if we divide 30 by 5, we have 6. As with any inverse calculation, just check it back. So now we've got the 6, let's start from the beginning and use the initial formula, the initial rule. 6 times 5 is 30, plus 3 is 33, so that works. Let's now go to our 58. We first of all subtract the minus 3, we subtract the 3, sorry, which is 55. Then we divide 55 by 5, which is 11. Let's test that. 11 times 5 is 55, plus 3 is 58. Yes, that works. Okay, let's go to our 93 now. So remember, we're doing the subtract 3 first, which is 90, and we're then going to divide 90 by 5. Okay, if you can't do that in your head, you can do a written method. So we can quickly divide that by 5. So 5 into 9 goes once with a remainder of 4, and 5 into 40 goes 8. Okay, and our final one, 128, subtract 3 is 125. I'm going to use the written method again. 5 into 1 doesn't go. 5 into 12 goes twice with a remainder of 2. 5 into 25 goes 5. So my answer is 25. And again, you can check those work by taking the 18 and the 25, multiplying by 5 and adding 3, just to check that it's correct. In your next activity, we are given an algebraic sentence where a letter is replacing a value. So if we read the top, when P equals 14, calculate the following. Number 1, 3P plus 7 equals. So in this activity, you need to replace the P with 14. Let's have a go at doing a couple of examples together before you have a go at the activity on your worksheet. So when P equals 14, what would 2P plus 9 equal? Now, important to remember that 2P actually means 2 multiplied by P. Okay, in algebra, we don't put the multiplication sign in between letters or in between numbers and letters. When the two different values are next to each other, it means to multiply it, okay? Now remember, the P equals 14, so we're going to substitute our P for 14. So if I wrote that out again, what I'm actually needing to do is 2 multiplied by 14 and then add 9. So if I did 2 times 14, I have 28. And if I add 9 to it, I have 37. Okay, let's look at our next sentence. I have 4P. So I have 4 lots of P. The first calculation I need to do is 14 times 4. So you may want to do a written method. 14 times 4. 4 times 4 is 16. 1 times 4 is 4, plus my 1 is 56. So my 4P is equal to 56, and I want to add 10. I can do that mentally, is 66. My next calculation, 8P, subtract 15. So 8 lots of P, 8 times P. Remember, P is 14, so we're going to do 14 times 8. 4 times 8 is 32. 1 times 8 is 8. Add my 3, it's 11. So my 8P is equal to 112, and I need to subtract 15 from that. So you might do it mentally, or you might want to do a written method. I'm going to do a written method here. 2 take away 5. I can't do that, so I need to borrow. 12 take away 5 is 7. 0 take away 1, I can't do that. 10 take away 1 is 9. So my answer is 97. Okay, my next one, 5P take away 28. 5 lots of P. Remember, P is 14. So I'm going to do 14 times 5. 4 times 5 is 20. 1 times 5 is 5. Add my 2 is 70. Remember, 5P, you could also have done 10 lots of P mentally, which is 140, then halved it. That would have also given you 5P. Use what methods you can use confidently and, more important, accurately. And then 70 take away 28. So you may do a written method like this. You may count up from the 28 and round up to 70. So let's use this method first. I can't do 0 take away 8, but I can do 10 take away 8, which is 2, and 6 take away 2, which is 4. What I might also have done is counted up from 28 to 70. I need to add 2 to get to 30, and then from 30 to 70 is 40, so that's 42. So use the method that you are confident with and also that you can do accurately. And our last one is 2p take away 32. So 2 lots of p, I can do that mentally. 14 times 2 is 28. This is 28. 28 take away 32. What do we notice here? Well, the number that we're subtracting is larger than the number we're starting with. Now, this method is not going to work. Do not use this method when you're going to have a negative answer. This does not work, okay? I've seen many people try this, but it doesn't work. What you can do is think about using a number line, okay? Best way to calculate a subtraction sentence where you know the answer is going to be negative. I know the answer is going to be a negative number because I'm taking away a larger number than the number I'm starting with. Now, you may have already done the calculate intervals across 0 video. If you haven't and you're unsure on how to do this, that's a great video to watch. You need to watch it at some point anyway, but that will give you a good basis for this. But for now, I'm just going to draw a number line. I'm starting at 28 and I'm subtracting, going backwards, I'm subtracting 32. Now, what you need to do is think about where 0 is. So I know that I'm going to go beyond 0. I'm going to go further than 0. So I'm going to put 0 about there. I'm going to change my colours so that you can just see clearly what I'm doing. So from 28 to get back to 0, I'm taking away 28. But I needed to take away 32. So how much further do I need to go? So I need to think about the difference between 28 and 32 here. I've subtracted 28 of the 32. I've got another 4 to go. Okay, now it's a bit clearer to see what my number's going to be. If 28 took me back to 0, from 0 I'm taking away 4. So I'm going to get to -4. My answer is -4. Okay, these number sentences of algebra, the answers can be negative as well as positive numbers. If you need to watch the video back again, do so. Otherwise, give it a go on your worksheet. Here we're going to look at an example of how you might use formula in real life. So many of us go on holiday, and when we go on holiday, we might need to change up our currency. So you may need to change up your currency for euros if you go in Europe. You may need to change up your currency for dollars if you go to America or Australia. But currency exchange is something that happens in real life. So in this example, we're going to look at changing up pounds for US dollars. And you can see that we have a formula. We have P multiplied by 1.3 equals D. And actually, remember, we don't need that multiplication sign. So let's have a look how to convert pounds to dollars and dollars back to pound using the formula that we've got. So if I had £10, I'm going to imagine that P stands for pounds and D stands for dollars. I've got my rule, I'm multiplying by 1.3. So the first thing I need to do is to substitute my P for 10. So I'm simply going to do 10 multiplied by 1.3. And my answer will be the amount I have in dollars. Put the pound sign there. Now, I'm multiplying by a decimal number, but I'm multiplying it by 10. So I'm going to use my understanding of multiplying by 10 to find out what my answer is. Now 1.3, if it gets 10 times bigger, each number is going to move one space to the left. So I'll have 13, and my decimal point will now be here. Remember, I don't need to put that in. So I can simply write it as $13, but the other way is correct as well. So £10, I'm going to multiply it by 1.3, which gives me 13, and that is how I convert my £10 to $13. Let's have a go at doing it the other way round. What if I know how many dollars I've got? Think back to the rule video that we had before. If we know what the end result is and we know what the rule is, how can we find what the starting value was? We're going to use the inverse. We're going to divide by 1.3. You may have watched some videos earlier about dividing. I can't divide by 1.3. You don't want to do 260 and put 1.3 outside. What I don't want is to divide by a decimal number. So to get rid of that decimal point, I need to multiply this number by 10 to make it 13. But I must also multiply this number by 10 so that the answer stays the same. 2,600 divided by 13 will give me exactly the same answer as 260 divided by 1.3. Check it on a calculator just so you can prove that yourself, but 2,600 divided by 13 will give exactly the same answer as 260 divided by 1.3. I do not want to divide. I don't want a divisor, which is a decimal number. I need a whole number here. So you can use this simple trick to help you. So let's go. Now, if you've watched the division video as well, you know that I like to do help boxes. So I might list my first few multiples of 13. Now I'm actually going to stop there because I can see in my number, my 26 is already there. So 13 into 2 doesn't go. 13 into 26, I can see in my list of multiples goes in twice. And I know that 13 doesn't go into 0 or 0. So my $260 is actually equal to £200. And that's how we convert back, by using the inverse. Okay, let's look at how we can solve some word problems. Now I've got my formula, P times 1.3 equals D. So the pound multiplied by 1.3 equals the value in dollars. And I've drawn up my pounds and my dollars with my rule, as we had done in the very first activity where we had our columns, our rule, and then our resulting column. You don't have to write it like this. This is just a good way to visually represent what you're doing. Okay, let's have a look at a word problem then. Amanda has £20 to exchange. How many dollars can she buy? So what information do I have? I've got my pounds. So I'm going to write in here my pounds. Now I can very easily see which way to apply my rule now. I know that I need to multiply it by 1.3 to get to the dollars. Okay, so there's two different ways you can do this. Well, there's more than two different ways. I'm going to do 20 multiplied by 1 and 20 multiplied by 0.3. I'm partitioning it. 20 times 1 is 20. And 20 times 0.3 is 6. If I know that 20 times 3 is 60, I know that 20 times 0.3 is 6. Again, we have videos on this in our calculation section, so make sure you watch that. So 20 times 1.3 is 26. She would be able to buy $26. Let's have a look at another question. Hema bought $260. How many pounds did she spend? Okay, so I can fill in 260 here. If I had $260, how many pounds were spent? Now I can already recognise in my dollar column that 260 is 10 times bigger than 26. That's going to help me to find out my pounds. But what would I do if I didn't have that first column filled in? Well, I'd need to do the inverse. I'd need to go this way and divide by 1.3. Remember what I said earlier, you can't divide 260 by 1.3. So I'm going to make it 10 times bigger, both sides. 13 into 2 doesn't go. 13 into 26 goes twice. We did this calculation before. It's 200. Okay, so this just gives you a way of taking a word problem and how you can present the problem in a systematic way. Well done, you've completed the activities and the tutorial on using simple formulae. Hopefully you now understand how you can find rules and how you can apply rules and how you can swap letters for numbers. If you're feeling confident, why not print off the past SATs questions so you can have a look at how this kind of math skill has been presented in past tests. Good luck!